So in this video lecture we will discuss about the iterative method to solve linear system of equations. So before defining linear system of equations, first of all we'll discuss vector norms, or before that we'll discuss vector belonging to Rn. Let Rn be the set of all n-dimensional column vectors with real numbers components. Okay, so if we are saying a vector x belonging to Rn, that means what? This implies that x is having n components, x1, x2 up to xn, where these xi's belonging to the set of real numbers. So Rn is what? That is the n-dimensional column vector. Okay, and x1, x2, xn are what? That is what? That is the real number I equal to 1 to up to n. So let us define vector norm. Vector norm is what? A vector norm on Rn is a function from Rn into R, that is, we can write it like that, with the following properties. First is norm of x is greater than equal to 0 for all x belonging to Rn. Second property, norm of x equal to 0 if for non-leaf x equal to 0. So a vector on Rn is a function from Rn to R. Rn is domain, R is real number. That is what? That is the that norm is what? That is starting from Rn to R. So Rn is domain and R is range. So first property is what? Norm of a vector is always greater than equal to 0. Second, if norm of a vector is 0, that means that vector must be 0. So norm of any vector is 0 in the case only whenever the number is 0. And third is what? Norm of alpha x equal to this x and this x is same. Okay, so I'm just confused with this. Norm of alpha x equal to mod of alpha norm of x, where alpha belonging to the real number and x belonging to Rn. And the fourth property is norm of x plus y is less than equal to norm of x plus norm of y for all x and y belonging to Rn. So there are four properties for vector norm. That is, first is norm of x is greater than equal to 0. That is, norm of x equal to 0 if x equal to 0, and multiply with the real number to the vector x, and then we'll take its norm. It is equivalent to absolute value of the number alpha or the real number into norm of the x. Okay, fourth property is what? Norm of x plus y is less than equal to norm of x plus norm of y. What this norm actually represents? The norm of a vector, the norm of a vector gives a measure for the distance between an arbitrary vector and the zero vector, just as the absolute value of a real number describes its distance from 0. Okay, so norm of a vector, if we are talking about a real number, then we are taking absolute value. If we are talking about the vectors, then we'll take norm. Okay, so norm and absolute value are same whenever we are taking a number belonging to the real number. So norm of a vector is what? That is denoting distance between the arbitrary vector and the zero vector. If we are writing norm of x, then x is what? X should be a vector, and norm of a vector is what? That is denoting the distance between the vector x and the zero vector. And absolute value we are writing, that means x belonging to real number. So norm and absolute value are same whenever x belonging to R only. Okay. Now, in our absolute value, you know the definition of absolute value. That is what? Definition of absolute value is what? X, when x is greater than 0. Okay. Minus x and x is less than 0. Okay. But how to compute norm of x? So we are using different measure of norms. So L2 norm is defined as L2 norm. L2 norm is what? Norm of x2 as summation x I square is to power 1 by 2. Okay, where x is what? X is x1, x2, xn transpose. And L infinity norm is defined as norm of x infinity equal to maximum of mod of xi. I is lying between 1 to 1. Okay, so L infinity norm is what? That is the maximum value of the component from x1 to xn. x1, x2, xn are the component, and whatever the maximum value of the component, that will assume as L infinity norm. And L2 norm is what? That summation of xi square is to power 1 by 2. Okay, let us take an example. Determine L2 norm and L infinity norm of the vector x as -1, 1, -2 transpose. So L2 norm is what? We are denoting L2 norm as norm of x2 equal to summation of xi square is to 1 by 2. I equal to 1 to 3. That is -1 square plus 1 square plus -2 square 1 by 2. Okay, it is square root of 6. Norm of x infinity equal to maximum of mod of xi. So out of this, whatever the maximum value, that is truth value. Okay. Graphical representation of L2 norm and L infinity norm. Okay, if we are writing here, suppose we are taking 1 0, this point is minus 1 0, and so this is 0 1, this is 0 minus 1. So L2 norm in R2 or we can say the vector in R2 with L2 norm. So I can write it properly. The vector in R2 with L2 norm less than 1 are inside this theta. That means what? This is what? This is a unit circle. Okay, unit circle. This is 2 dimension, x-axis, y-axis. So those vector whose L2 norm is less than or equal to 1, they are lying inside the circle. And L infinity norm, you can represent it as unit square. Okay, this is 1 0 minus 1 0, 0 minus 1, and 0 plus 1. So the vector in R2 with L infinity norm less than 1 inside this theta. Okay, so those vectors whose are vectors in R2, because it is 2 dimension, x-axis and y-axis with L infinity norm, and the norm is less than 1, that will be inside this square. So L infinity norm in R2 less than is a square, is a unit square. Okay, next is distance between two vectors in Rn. Distance between two vectors in Rn. Suppose x is a vector x1, x2, xn transpose, and y is y1, y2, yn transpose. These are belonging to Rn. Then L2 norm x minus y is defined as summation xi square minus yi square, xi minus yi square raised to power 1 by 2. Norm of x minus y infinity, maximum of mod of xi minus yi. I is lying between 1 to n. Let us take some examples. Suppose the linear system of equation ax equal to b has exact solution in x equal to 1, 1, 1 and approximate solution x transpose as 1.2001, 0.99991 and 0.92538. transpose. Determine L2 and L infinity distance between the exact and approximate means solution. Okay, so norm of x minus x bar infinity is coming out to be what? That will be maximum of 1 minus 1.2001, 1 minus 0.99991, and 1 minus 0.92538. Okay, transpose. The value is coming out to be 0.2001. You can verify it by yourself. And the value and norm of x minus x bar is coming out to be 1 minus 1.2001 whole square plus 1 minus 0.99991 whole square plus 1 minus 0.92538 whole square. The value is coming out to be 0.21356. So this is the distance between the vector exact and approximate solution of the system Ax equal to b. Next is matrix norm. So matrix norm on the set of all n by n matrices is a real valued function defined on this set, satisfying for all, satisfying for all n by n matrices A and B and all real number alpha. So matrix norm on the set of all n by n matrix. Suppose there are two matrices A and B, and that is what is a real valued function dot defined on this set, satisfying for all n by n matrix A and B and for real number alpha. That means what? Suppose A and B are two matrices and their order is what? N by n. Both are having same order. Then matrix norm is denoted by this symbol, is defined as norm of or having the following properties as norm of A is greater than equal to 0. Second property of the is what? Norm of A equal to 0 if and only if A equal to 0. So norm of A matrix is 0 if and only if the matrix is 0. Number 3 is what? Norm of alpha A equal to mod of alpha norm of A. It is similar to the vector norm. Fourth property is what? Norm of A plus norm of B is less than equal to norm of A plus norm of B. It is having one more property, that is what? Norm of AB is less than equal to norm of A into norm of B. So matrix norm on the set of n by n matrix is a real valued function. That means it is defined from the set of matrix n by n to real valued function. So ultimately what we are getting range as real valued function. Okay. So norm of A equal to A is greater than or equal to 0, and this is what. So L infinity norm and L2 norm are defined as maximum of summation Aij j equal to 1 to n, and I is lying between 1 to n, where A is what? That is Aij and y. Okay. Let us take an example. Suppose A is a matrix 1, 2, minus 1, 0, 3, minus 1, 5, minus 1, 1. Okay. So A infinity norm will be what? It will be maximum of I is lying between 1 to 3, summation A I j is 1 to 3. Okay. So it is coming out to be maximum of, it is sum column wise. Okay. So maximum of 1 plus 2 plus 1. It is 3. That is 1 plus 2 plus minus 1. 0 plus 3 plus minus 1. 5 minus 1. 1. It is coming out to be 4, 4, 7. This is 7. So this is identity norm of the matrix A. Now L2 norm of the matrix A. L2 norm of the matrix A. What is L2 norm of the matrix? It is defined as norm of A, row of A transpose is for 1 by 2. What does it mean? It means that rho is stand here for spectral radius. Rho is stands for spectral radius of a matrix with this it is associated. Suppose row of B, matrix A. Okay. So what is row of B? What does it mean? Spectral radius means what? That is maximum of the lambda, where lambda are the eigenvalues of matrix B. So just keep in mind. So this you can say. So just keep in mind. So rho B is called the spectral radius of the matrix. So that is it is associated. So rho B is defined as maximum eigenvalue of the matrix A. Okay. So maximum, if B is a matrix of what is 3 by 3, then 3 eigenvalues of the matrix exist, and out of 3, whatever the maximum eigenvalue, that will be the spectral radius of the matrix A. So L2 norm of the matrix will be what? That will be the spectral radius of the A transpose A. So we can say A L2 norm is what? That is the square root of the spectral radius of A transpose A, or we can say the maximum eigen value of A transpose A. That is the answer. Okay, how to compute eigenvalue of matrix? What is the eigenvalue? So define eigenvalue. You have already studied this course in this topic, eigenvalues, in the first year. So eigenvalues and eigenvector. A is a square matrix. The characteristics polynomial, the characteristic polynomial of A is defined by mod of A minus lambda I equal to P lambda. Then P lambda is what? Characteristic polynomial. Characteristic polynomial. Then the zeros of the roots of P lambda are the eigenvalues of A. Of the matrix A. So we can write Ax equal to lambda x. Physically we can write Ax equal to lambda x. A is a matrix that will transform the vector x into a vector x multiplied by some number lambda. This lambda is what? That is called the eigenvalue of the matrix A. Okay. So what A is doing? A is transforming x into lambda into x form. So x into lambda. Suppose x is a vector, this is x vector, and lambda is what? That is suppose half of this value. X is this vector and lambda equal to 1 by 2. So lambda x will be what? Lambda x. Okay. So lambda is what? That is the number that will that is the number that by which the vector x, just keep in mind x is a vector. Okay. A is a matrix. A is transforming the vector x into lambda into the original vector x. Okay, so whatever the number is multiplied to the original vector x, that is called eigenvalue of the matrix. Okay. So how to compute eigenvalues? Let us explain it with the help of example. There is a matrix 2 0 0 1 1 2 1 minus 1 4. Okay, A minus, we can write it A minus lambda I as A minus lambda I, that is 2 minus lambda 0 0 1 1 minus lambda 2 0 0 1 minus 1 4 minus lambda. Okay, find out determinant. Okay, its determinant is coming out to be what? It is lambda minus 3 and lambda minus 2 whole square. Okay, it is coming out to be 0 because this is A minus lambda is, we are taking a determinant of A minus lambda is equal to 0. That will give us the equation in lambda. So this is the equation in lambda we are getting, and compute the value of lambda, that is coming out to be 2, 2 and 3. So what is the spectral radius of A? So rho of A is what? That is the maximum eigenvalues, that is maximum of 2, 2, 3, that is the, so rho of A is what? That is the, and eigenvalues are what? 2, 2, 3, that we have completed here. Okay. This topic I just mentioned because how to compute eigenvalues, otherwise this topic is already discussed in your first year. So suppose we are taking one example. Determine L2 norm of the matrix A. A equal to 1, 1, 0, 1, 2, 1, minus 1, 1. Okay. So solution A transpose A. A transpose is what? 1, 1, minus 1, 1, 2, 1, 0, 1. A is 1, 1, 0, 1, 2, 1, minus 1, 1, 2. A transpose A is coming out to be 3, 2, minus 1, 2, 6, 4, minus 1, 4, 5. So find eigenvalues of A transpose A. So A transpose A minus lambda is equal to 0. So it is coming out to be 3 minus lambda, 2 minus 1, 2, 6 minus lambda, 4 minus 1, 4, 5 minus lambda. Okay, determinant of this is equal to 0. What we are getting here minus lambda, lambda square minus 14 lambda plus 42 equal to 0, and the value of lambda is coming out to be 0. 7 plus under root 7 and 7 minus under root 7. So norm of A transpose is what? That is the maximum of A transpose A. That is the rho of A transpose A. Just spectral radius of A transpose A. So what is the maximum value of out of these things? 7 plus under root 7. The value is 3.10. Okay. So done. Now let's discuss. Now come to the topic. What is the topic? Find the solution of the iterative solution of the system of linear equations. So how to write system of linear equations? So system of linear equations. Write Ax equal to A. What is Ax? A11 x1, A12 x2, A13 x3, A1n xn equal to B1, A21 x1, A22 x2, A23 x3, A2n xn equal to B2, an1 x1, an2 ann xn equal to 1. System of, so this is what? This is a system of n linear equations. N equation. So the very first method that we are going to discuss, the solution of system of linear equation, that is the Jacobi method. So what is Jacobi method? Jacobi method. What we'll do, we assume here, we'll write first equation as x1 as b1 minus a12 x2 minus a13 x3 and so on minus a1n xn. Okay, and then we'll divide it by a11. Similarly, we can write second equation as x2 will compute from here v2 minus a21 x1 a23 x3 a2n xn upon a22. So what we did here, we computed the value of x1 from the first equation, x2 from the second equation, xn from the another equation. Okay, we'll keep left hand side as x1, x2, x3 and xn, and everything will take on the right hand side. So that we have written like that. Now xn equal to bn minus an1 x1 minus an2 x2 an n minus 1 xn upon ann. Okay, or in general we can write here xi equal to bi minus a ij xj, j equal to 1 to n, and j is not equal to I. If we are computing xn, so xn is not in the right on the right hand side. Okay, upon aii. Okay, so for I equal to 1 to 4. Now what we can do, we'll make it iterative scheme. In order to make it iterative scheme, what we do, we'll take right hand side as k plus 1, sorry, left hand side as k plus 1 and right hand side will keep as k. This k is representing what? That is the iteration. So k is denoting what? Iteration. In order to apply iterative scheme, we should know right hand side in advance. So for that we require initial guess. As we the same procedure will apply that we followed in Newton-Raphson method, secant method. There we have write a scheme in terms of the iterative form, and then right hand side we assume as known solution. So we'll use some unknown. So kth iteration, k is greater than equal to 1. So what we do, we'll assume here for k equal to 0, k is greater than equal to 0. K equal to 0, that means the x1 0, x2 0, xn 0 will assume to be known. Okay, or will how to known, will get the value of these x1 0, x2 0 as by guess. Okay, to be known, we'll guess these values, and then we'll apply iterative scheme. How to do that? How to do that? We can write the value as, let's explain this method by the example.